Hello everybody and welcome into another video on RStudio. Today we're going to take a look at the basic layout and work with some of the basic objects inside of RStudio. To begin, let's go ahead and open RStudio. You can do this by selecting the Start menu on a Windows computer and scrolling down into R. And be sure to select the RStudio folder and click RStudio. This should bring up a new RStudio window. And the first thing we're going to do is add a new script. And there are two ways to add new files or new panels into RStudio. We can go to File, New File, and then select the type of file that we would like. Here we can click RScript. The other option is right underneath the File menu. We have this plus symbol, and we can click the New File RScript from the submenu. Once you've added a new RScript, your window should look like this. It's divided into four main panels. We have our script panel, which we just opened up. Below it, we have what's known as the console. And then on the right-hand side, we have currently the Environment tab and the Plots tab open. For right now, our RScript is titled Untitled1. If we want to change the title of our RScript, we can go to File, Save As, and then we can type in the file name of our choice. In this video, we'll be looking at data types, so I'm going to save my file as data types, and then I can select where I would like to save this. Right now it's being saved inside of Documents, and that should be okay. In R, there are 6 basic data types, and we're going to go over the most common data types that you will see. So let's begin by assigning to an object a number. Now what we're going to be telling R to do here is to take the number 30 and assign it to the variable called capital A. And there are two ways to run this code in R. We can highlight the code that we would like to run, and we can click the Run button. The other option is to have our cursor after the line of code we would like to run. So here I have my cursor after the number 30, and I hold down the Control button and hit the Enter key. This will also run that line of code, and we can see that that has been done down here in the console. Now what I'd like you to notice is that over inside of the Environment panel, we now have something new. We have a Values submenu that says A is equal or equivalent to the number 30. Every object that we create inside of R has attributes. For simple objects, like the objects we will look at in this video, we have two attributes we can ask about. We can ask about the class of the object, as well as the length of the object. For example, if we're curious about the class of object A, we can type the word class with a set of brackets, and we can put the object inside of that set of brackets. So here we've typed out class of A. And if we use Control-Enter to run this code, what we're going to get inside of the console is the answer to our request. The class of object A is called Numeric. This is our first data type. So if you need to, pause the video so that you can type out or copy the code that I have inside of my script. What we're going to do is we're going to assign to capital A the number 3.14. We're going to attempt to assign to B the number pi, and we're going to see if R recognizes pi as the true irrational number pi. We're going to assign to C the number -25, and we're going to try to assign to D Euler's number E. When you're ready, let's go ahead and highlight all 4 lines of this code and click the Run button. Notice that inside the console, all 4 lines of my code have been executed. And the first thing to notice over in the environment window is that A, which used to be the number 30, has now been updated to be the number 3.14. Notice that B does indeed have the decimal approximation for the true value of pi. C is -25, and D has the decimal approximation for what is known as Euler's number, which is represented with the letter E. Next, let's try to do some basic mathematical operations with these numbers. If you need to, pause the video so that you can copy the code that we've written down inside of our script. I'm going to choose to run each line here one by one so we can analyze what happens. Using Control-Enter on line 9, we can see that A plus B returns back to us about 6.281593. This is a decimal approximation of the sum up to 6 decimal numbers. Next, running line 10, we get the subtraction of A take away C. Next, we can use the star operator, which is Shift 8, in order to perform multiplication. B times C returns back to us about -78.53982. To do a division, we use the backslash operator, which is found to the left of the Shift button, and C divided by D returns back to us about -9.196986. We can attempt to find the square root of a number by using the function sqrt and putting the variable that we want to find that square root of inside of the brackets. So line 13 is attempting to find the square root of -25, and what we get in return is an NaN. This means not a number. In this case, we can't take the square root of a negative value, and R is going to tell us that this value that we get is not a number. It does not know how to do this computation. And then finally, if we ever need to raise a number to a power, we can use Shift 6. Here, A to the power of C, or 3.14 to the power of -25, gives us about 3.77 times 10 to the -13. So be mindful that if you ever get output that looks something like this, this indicates that we typically have a very small decimal number. There are 2 other things that you should keep in mind when working with computations inside of R and RStudio. The first one occurs when we attempt to do a division by 0. Let's say we take the number 1 and we try to divide by 0. If I run this line of code, inside of the console I get INF. This stands for infinity. R can't tell us whether or not the infinity is negative infinity or positive infinity. Whenever we get a division that causes this kind of problem, R is just going to return back INF. And the last thing we need to be mindful of is, since we're working with a computerized language, we need to know how this language is going to treat an operation like the logarithm function. So let's run log on the number 10 and see what we get. If the logarithm function inside of R was log base 10, we would expect the output in the console to be the number 1. Since this output is about 2.3, I suspect that this log function is actually the natural logarithm, or the logarithm of base e. And we can check to see if that is the case by attempting to evaluate logarithm of capital D, or the logarithm of e. And when we run this line of code, we get the number 1, indicating that R is going to treat the logarithm function as the natural logarithm.